Welcome to the Explainer. We're often faced with this common headache, messy data, full of duplicates. Well, today, we're going to fix that with one of Python's most elegant and honestly most useful tools, the set. Okay, so let's set the scene with a super common problem. You've got a list of stuff, right? Like this one here, a list of restaurant orders. You can see it immediately. McDonald's is in there twice. This kind of thing happens all the time, and cleaning it up can be a real chore. So the mission is simple. We just want a list of the unique restaurants. Now, sure, you could write a whole loop to go through and check every item, but there's a much, much cleaner way to do it, a more Pythonic way. So how would you handle it? And here it is, the magic trick. This one single line of code does everything we need. By just converting our list to a set, we instantly vaporize all the duplicates. Then we just pop it back into a list. It's clean, it's super readable, and it is wicked fast. So what exactly is this thing we just used? Well, a set is basically a special kind of collection, and it lives by two really important rules. First, every single thing inside a set has to be unique. No duplicates allowed, period. And second, it's unordered. The items don't have a position or an index. This also means everything in a set has to be hashable, which is just a techie way of saying it has to be something that can't be changed, like a number or a string. But here's the thing, sets are so much more than just a tool for getting unique items. They come with this incredible toolbox of operations that let you compare and combine collections in really powerful ways. Let's open up that toolbox, and first up is union. A union is all about merging two sets together. You can either use the .union method, or my personal favorite, just this simple vertical bar, the pipe operator. And check out the example. See how the number 3 is in both of the original sets? But in the final result, it's only there once. That's the set doing its magic for you. It's perfect for when you need to combine two lists and just automatically get rid of any overlaps. Okay, so that's how you bring two sets together. But what if you want to do the opposite? What if you need to find only the things that two sets have in common? For that, we've got intersection. You can use the .intersection method or just the ampersand symbol. And what it gives you is a brand new set with only the elements that were found in both of the originals. So in our example, that's 3, 4, and 5. You can think of it like finding the mutual friends you have with someone online. All right, next up is a really handy one, finding out what's in one set but not in the other. This is the difference operation, and you can just use the minus sign. It's literally like subtraction for sets. It takes the first set, and then it removes anything that also happens to be in the second set. So here we start with 1, 2, 3, and 4. We subtract the common elements 2 and 3, and we're left with just 1 and 4. But what if you want the total opposite of intersection? What if you want to find everything that isn't shared between two sets? For that, there's the symmetric difference, and you can get it with this little caret symbol. Now this one is really cool. It gives you all the elements that are in one set or the other, but specifically not in both. It finds all the unique items on the fringes of both collections. So now that you've got the basic moves down, let's get into a couple of pro tips. First, let's talk about how to remove things from a set without accidentally blowing up your program. There's a very subtle but incredibly important difference between using .remove and .discard. Yep, they both get rid of an element if it's there. But, and this is the important part, if the element you're trying to remove isn't in the set, .remove will throw a key error and crash your code. .discard, on the other hand, just does nothing. It shrugs and moves on. That makes .discard the much safer, more robust choice most of the time. And speaking of doing things the smart way, here's another key tip. All the operations we've seen so far, they all create a brand new set in memory. But when you start working with really, really big data sets, it's way more efficient to modify a set directly, what we call an in-place operation. So these are the in-place or update versions of what we just learned. So instead of SRT creating a new set, using SI equals T or S.updateT actually changes the original set S. This is a huge optimization to keep in your back pocket when you're dealing with a ton of data and memory is a concern. So we know that sets have to contain unique, unchangeable items. But that raises a fun question. What happens if you try to put a set inside of another set? Well, you'll immediately hit this type error. And the reason is pretty simple when you think about it. Remember how we said things inside a set have to be unchangeable or hashable? Well,
A regular set can be changed. You can add or remove items from it. So because a set is mutable, Python says, nope, you can't put that in another set. And the solution to this puzzle is the frozen set. It's exactly like a regular set, but with one massive difference. It's immutable. It's frozen. Once you create it, you can't change it. And because it can't be changed, it's hashable, which means Python is perfectly happy to let you stick it inside another set. Problem solved. Now, sets are incredibly powerful, for sure, but they are not always the right tool for the job. Let's look at a case where using a set could actually make you lose some really important information. So check this out. Our input list has the letter B in it twice. And when we turn it into a set, it does its job perfectly. It gives us the unique items, A, B, and C. But we've lost something critical. We've lost the count. We have no idea anymore that B was the most common item in our original list. So when the count matters, what you actually need is something called a multiset. And Python has the perfect purpose-built tool for this, the counter object from the collections module. It acts a lot like a set, but it also keeps track of how many times each item shows up. It's really the best of both worlds. Okay, let's do a quick recap of the key points. Sets are your absolute go-to for unique, unordered data. You can use those simple operators like the ampersand and the pipe to do powerful comparisons. Always try to use .discard for safe removal. If you need a set that can't be changed, you've got frozen set. And if you need to count things, don't use a set. Reach for counter. So there you have it, the Python set toolbox. These things aren't just some obscure data type. They're a fundamental tool for cleaning, comparing, and analyzing data. They give you a really simple and elegant solution to what can often be very complex problems. So now that you've got these tools, what are you going to solve with them?